In this section, we're going to look at exponential functions. So first thing you need to ask yourself, what does it mean to grow exponentially? Can you remember? What you see here is a green dot that's assumed to be a zombie, or you can think of this as an infection, and these are red blood cells. It took about 5 seconds for this to infect its first person. Now think, looks like we could be here a minute for it to affect everybody, but let's see it in exponential growth live. And that was about 33 seconds. So it took 5 minutes for one, and then 33 seconds for the rest. Notice how when it got to a point that it was all overrun, that it just took over. People were getting infected left and right. Here is our graph of an exponential function. Notice our variable x is in the exponent part. Now, as we see here, my first value at 0 is a 1, and then at 1, it's a 2, and then at 2, it's a 4, and then at 4, I'm out of the scale here. I'm all the way up here in 16, and then look at 10. How far we have to zoom out just to get to 10. That is exponential growth, something that grows really, really fast. Takes a little while to gain steam, but once it gains steam, it's off the charts. One thing also I want to note about the graph is that exponential functions have a horizontal asymptote. So as I see here in this one, as our graph moves up and down, so does our horizontal asymptote. Now another example of exponential growth is the COVID infection rate. COVID-19. Want to know why we had a government shutdown? It's because look what was happening in April. Does this not also look like our exponential growth here? Sure does. This is what they didn't want. They didn't want for these numbers to get around here in the 10 range for this to go off the charts. So we performed a government shutdown, required people to wear masks to kind of level this off. Now, the big takeaway from this section, though, is being able to compute interest. How much money you make on investment or how much you have to spend based on money given to you. We're going to look at 3 types of interest. Simple interest, I equals PRT. Compound interest, so you're getting several payments each year. And then continuous interest, which has this E, which I'll explain later. Looking at the first one, simple interest. Suppose that $15,000 is invested with 2.5% interest for 7 years. Find the simple interest. First, we need to define our variables within our formula. So the P here is principal. That's how much money you started out with. So I started out investing $15,000. So for my P, I'm going to put $15,000. And then my R is my rate. My rate here is at 2.5%. Now when you put in here, you have to change this to a decimal. So that's 0.025. So take this number and divide by 100. That's going to give you your decimal value. And then my time. How much time am I investing? In this case, 7 years. So I'm going to put 7. So all you need to do in your calculator is do 15,000 times 0.025 times 7. And I made $2,625 from this investment. $2,625. That's how much interest I earn or how much interest I have to pay. Note that if I want to see what's going to be at the end of my bank account, I need to take $2,625 and add it to my principal, $15,000. That's going to give me the total of my account. This just tells me how much interest is earned or that I have to pay. Now let's look at compound interest. Suppose that $15,000 is invested with 2.5% interest for 7 years. Find the interest compounded quarterly. A new type of term here because we have a new variable, N. N refers to the number of compounded each year. Quarterly would be 4 times a year. Now if this said annually, my N would be 1. If this said monthly, my N would be 12, etc. So let's plug in our values. So P is my initial value. So in this case, I started with, again, 15,000 times 1 plus my rate, so at 2.5%, so 0.025 over n, 4 times a year. And now this is not times, this is raised to the power of n, which is 4 times a year times time for 7 years. Now be very careful when you plug this into the calculator. Make sure you don't make any mistakes. I would do this several times just to make sure you get the same number. So what happens? My compound interest here. Now note, after you do this calculation, unlike simple interest where it just gives you the interest, this gives me the total amount in my account. So you need to take the number after you do that formula and subtract it from your principal, so 15,000. So subtract this from 15,000. Gives me how much interest I earned. I earned $2,858.96. Now the ultimate kind of interest is continuous interest. Suppose that 15,000 is invested with 2.5% interest for 7 years. Find the continuous interest. Note the big change with this formula. That is, we have an E here. This is Euler's number, and this next video is going to display Euler a little bit better than I can.
Bernoulli first defined E through compound interest. Now, compound interest says that you get a little bit of money in interest every period, and that money you gained helps you gain even more interest next period. In other words, your interest compounds. So if you stick $1 into a bank account with a 100% interest rate compounded annually, you'll get $2 at the end of a year. If it's compounded semi-annually, you'll end up with $2.25. Quarterly, and you'll end up with $2.44. Monthly, $2.61. Weekly, $2.69. See where we're going? If you increase the number of compounding periods a year towards infinity, then you'll get closer and closer to E dollars.
So for this problem, I have P, my principal, at 15,000, times E, Euler's number, raised to the power of my rate, so 0.025 times T, 7 years. So make sure you're very familiar with E is on your calculator. For the graphic calculator here, E is right here, so second ln, when I want to plug that in. So let's do our calculation. 15,000 times Euler's number, raised to the power of 0.025 times 7 years, gives me a total account of 17,868. Remember, this is account, so I have to subtract that from my principal. Gives me my interest of $2,868.69. This is the max amount of interest you could ever earn. So if you go to compound interest and do seconds, do milliseconds, it's eventually going to trend to this number here, your Euler's number. This is the most amount of interest, the interest you'll never find to gain, and hopefully you'll never have to pay in real life.